In this video, I want to take a look at how to write the equation of a line when we are provided the slope of that line and a point that we know that that line goes through. So essentially, we have a solution to our equation already, one of an infinite number of possibilities, but you have to have one in order to be able to write that line. So right away, something to keep in mind as we're going through these is points. When that point is provided to us, we are given an x value and a y value, and it's always x comma y. Now our goal is going to be to write the equation of a line in slope-intercept form, which is in y equals mx plus b. So that slope-intercept form is y equals mx plus b, where m is our slope and our b is representing the y-intercept. Now, when we look at that, if the y-intercept is given to us, we can jump right into that form. But for a lot of the times, the solution that we're given or the point that we're given is not, in fact, the y-intercept. And so what we can do instead is we can start with this slope-intercept or this point-slope form right here. So that form, that y minus y1 equals m times x minus x1 is called our point slope form. So this right here is called point slope form. And when we think about it, why it's called that is because we have a point in there, the x1 and the y1, and then we have the slope m. Okay? And so when we look at this problem, this first one, we are given a slope of 7. So that slope, that number 7 is our m. And we're given the point 1 comma negative 5. Now, again, that x value, I'm going to go ahead and label that as my x1. And this y value of negative 5 as my y1. And so because I'm given the slope and a point, I'm going to start with my point slope form. The y minus y1 equals m times x minus x1. And then I can fill in the corresponding numbers in the correct spots. And so right here, I can plug in this 7 for that m. Okay, I'm never going to plug in anything for these normal x and y. Right, these variables x and y. I know I'm going to have those in my final answer as soon as the 7 is given to me as a slope. You can see in some of the later examples down here, when we have a slope of 0 or a slope that's undefined, we might not have both variables x and y in our final answer, but anything that has a slope of a positive number or a negative number, or really anything that's not 0 or undefined, we know that that line is going to be slanted, and so we're going to have an x and a y in our final answer. It should come out looking like this blue highlighted slope-intercept form when it's all said and done. And so now here, when we plug in these x and y values, we just need to be very careful, because when I'm looking at this x1 is positive. It's a positive 1. But in the formula, I'm doing x minus x1. So this minus that I just wrote is coming from the formula here. Okay? And then my x1 value is positive 1. So I end up, even though my x1 value, my x of the point that was given to me, was positive, I end up with an x minus 1 in my formula, or my equation. Now, the same thing's going to happen with this y value, this y1 of negative 5, when I plug that in, except look at what's going to happen. I'm going to have a minus here, that's from the formula, and then I have another minus because it was negative 5. And so what ends up happening is when I take that y minus a negative 5, those minuses end up becoming a positive. So it's y plus 5 equals 7 times x minus 1. Now, that right there, that y plus 5 equals 7 times the x minus 1, is the equation of a line. It's just in point-slope form. And the instructions want us to have this answer in slope-intercept form. And so I'm going to need to take this further by distributing the 7 here. to get rid of the parentheses, so that's going to give me a 7x minus 7. The y plus 5 is going to stay the same on the left. And the last thing that I need to do is subtract this 5 over. Really what I'm trying to do here is solve for y, converting from this point slope into slope intercept. So getting the y by itself. And so the last step is to simplify that down. That's going to give me a y equals 7x minus 12. And so that last step there, I was converting, or the last two steps, I was converting from point slope into slope intercept form. And so now I can confirm again when I match these things together, right, to this y equals mx plus b right here. The number in front of the x should be my slope. That does match what I was given. And then I also have my y-intercept, and if I were to graph this line, I would see that it crosses the y-axis at negative 12, 0, negative 12. But this would be my final answer, y equals 7x minus 12. Okay, so we can look at another one here. Now on this one, right away, I'm told that the point given to me is my y-intercept, even if this was just labeled as point, right? I would still know, or hopefully I would know, that this is a y-intercept because this x value right here is 0. And so any point where the x value is 0, that is a y-intercept. It's where it's crossing the y-axis. So again, I have my slope. Now, because this is my y-intercept, I have this slope-intercept form, which uses the slope and a y-intercept. So just to back up here for a second, right, when I'm looking at this y equals mx plus b, this m represents my slope, and b represents my y-intercept. And so when I'm looking at this, if I identify the point given to me as a y-intercept, I can take this y value and just know that that could be my b value in that equation. And so I don't need to solve or plug in using my point slope and then have to rearrange the problem like I did in example 1. I could jump straight to starting with my slope intercept form, plug in my slope for m, and then my y-intercept here is negative 4, 0 comma negative 4, so that's going to be a minus 4 for this line, and this would be my answer. So when we have the y-intercept, it's a lot faster of a problem just because we don't have to plug in and then also have to rearrange. Okay. Let's look at one that has a fraction for a slope, right? My slope is also negative, right? So right away, I'm already thinking that's a negative number, but it's not 0, it's not undefined, and so I should have both variables y and x in my final answer because this is going to be a line that is slanted. It's just doing so in a negative fashion. It's going to, if I was to look at the graph, I would see a line that's going down from left to right. And then I can also label this point as my x1, y1. Okay, and so I'm going to start with that point slope form again. Okay, I start with it for every problem so that I can know exactly where I need to plug everything in at. And so I'm going to go in order from left to right here. So this is going to be a y. Now, just like the last one, or number 1, right, when I look here, when I plugged in this negative value for y, it ended up being positive. So I'm just going to skip that step this time and go straight to, all right, this is a y plus 2 because I was taking y minus negative 2. Plug in my slope of negative 5/4, x minus 8. And then again, this is in fact a line that has that slope of negative 5/4 and goes through the point 8, negative 2. It's just in point slope form. And so I need to rearrange this problem a little bit in order to get it into slope intercept form. And so again, I'm going to take this negative 5/4, this entire fraction, and distribute it to both things. That's going to give me a y plus 2 equals negative 5/4 x. Now negative 5/4 times or multiplied by a negative 8 is going to be positive 10. Okay, and so then I can subtract the 2 from the other side, from the left, and that will give me an answer of y equals negative 5/4 x plus 8. And so that is in slope-intercept form, where I have a slope of negative 5/4. That checks out because that was given to me. So I need to make sure that I have that. And then I have my y-intercept now as well. And if I graphed this, I should be able to see that it does, in fact, go through the point positive 8, comma, negative 2. Okay. Now I'm going to skip number 4 just for some time and jump right to 5 because it is a little bit different. And right away, number 5 here is different in the fact that the slope is 0. And so automatically what should be going off in my mind as I'm doing this problem, as soon as I see that slope of 0, is that this is going to be a horizontal line. It's going to be perfectly flat if I graphed it because of that slope of 0. And horizontal lines do not have both variables in their final answer. Okay, in fact, right, we have this device that I'm going to put over here. It's called Hoy-Vux. Okay, Hoyvux, Hoy-Vux. And it's split into 2. Okay, and so what that stands for is horizontal, slope of 0, y equals a number, vertical, undefined, x equals a number. And so how that's useful for me on this problem is, right, again, slope of 0 told me that I should have, this is a special situation here. My line's going to look a little bit different because that slope of 0 means that I should have y equals a number. So y equals a number, and x will not be involved in my answer. And so the number that I need to set this equal to, in order for it to go through the point 2, comma 5, is that y value. And so my answer here would be y equals 5. Okay, and so where this comes from, again, even if I didn't have all of that, I could have used the other methods to arrive at that same thing. So I can do that here for us. All right, so here's my x1 and my y1. I can plug all those in, starting with my point slope form. And so that's going to be a y minus 5 equals 0 times x minus 2. Well, that 0 on the outside of the parentheses is going to knock out everything on the right side. And so I get y minus 5 equals 0, which I could then add that 5 over to get the y by itself. And would you look at that, I get y equals 5 again. And so that Hoy-Vux is just a mnemonic device to really help shorten the problem, right? If you really understand and you immediately saw, all right, a slope of 0, that means it's horizontal. I know my equation should just be y equals a number. In the same capacity that when we look at number 6 here for a slope that's undefined, automatically I know this one is going to be a different situation than the first couple of problems we did, because if I went to try to do it like I did 1 and 3, I can't plug the word undefined in for my slope, right? That would be plugging a word into an equation, and that's just weird from the beginning. And so automatically I know that something is off about this problem, or just different about this problem. And the thing that's different is the fact that this undefined should automatically tell me that this is a vertical line, right? And so if it's vertical, going back to my Hoy-Vux again, that is x equals a number. And so this then tells me I should have x equal a number as my equation. The variable of y will not be in my answer at all. And what better number than the x value to make this equal to? So x equals 1 would be the vertical line that has a slope that's undefined and goes through the point 1, comma, negative 5.